Hello everyone, my name is James Ryan and I am here to teach you guys how and why division techniques work. Now, I'm not talking about what division is and why we use it and how it is and how it works mathematically. I'm talking about the division techniques you learn in primary school and how and why they work. Specifically, I'm talking about short and long division because that's how I learnt. That's what I learnt. And, short and long division are pretty much the same thing, just different ways of writing the same thing down. But let's talk about what we're actually doing when we are doing a division problem, when we are solving a division problem, and why it works. Now, I'm going to be using long division, but it doesn't really matter but that's just because it's better graphically, and and it's easier to work things out with. But short division is pretty much the exact same thing, but less working out is shown basically. So, let's think about how we'd solve this normally. Normally we'd just say, okay, how many times does 12 go into 3? None, so we could put a 0 here. How many times does 12 go into 30? 12 goes into 30 2 times. Remainder is 6 because 30 take away 24 is 6. And then we'd carry over the 4 and we'd do it again. But wait, slow down, too much. What's actually going on here? Alright. One very important fact you will have learned in primary school is expanded notation. And the way this expanded notation works is it shows off one of the very fundamental aspects of the way we represent our numbers. Each digit in a number represents the value of each digit in a number is represented not only by what that digit's value is, but also by its place in the number. The digit on the left is the most significant digit, and the digit on the right is the least significant. What this means is that the 3 in 3048 is short for 3000. It is not just a 3, it is 3000. Likewise, the 4 is short for 40, and the 8 is just 8. This is a very important fact once you realize what we are actually doing with division. Are we really trying to figure out how many times 12 goes into 30? No. We are writing down how many times 12 goes into 3000, because that's where this 3 is. This 3 is short for 3000. So one way to quickly figure out how many times how many times 12 goes into 3000 is not to ask how many times 12 goes into 3000 at all. You just ask how many times does 12 go into 30? And then multiply that by 200. Multiply that by 100. Because by doing that, you're essentially figuring out how many groups of 112s can I stick into 3000. So you say, okay, 12 goes into 30 2 times. So you write the 2 here. But notice where the 2 is. It's a 200. But we still leave these blank, because these decimal places blank because we've yet to fill in those less significant digits. But the most significant digit in this equation, 2, has been filled out. Now you're wondering, why is the 2 here? Why is it that we first have to check that 12 goes into 3? Well, because when we put 12 into 30, what we are checking is how many groups of 1200 can we put into 3000. If we were to start off with 3, we'd be checking how the 1 and 2 would essentially be here. And we'd be checking how many groups of 12,000 could we put into 3000, which doesn't go. So we know it doesn't go, so we just put a 0, and then we check. Okay? Now what about the remainder? Minus 24. And that gives us 6. Basically, we're saying that 12 does in fact go into 30 24 times, but there are 6 left. How does this translate into what's actually going on? Well, I know I said that what we're asking is how many times does 12 go into 3,000, but because what we're doing is how many times does 12 go into 30, and then timesing that by 100, what you're essentially saying is not how many times does 12 go into 30, but you're asking how many times does 1,200 go into 3,000. I already told you that, but just to reiterate. So this leftover 6 here, what this represents is that there's a 600 left over. Because after that 24,000, if you tried to get another 12,000 in, it wouldn't work. So basically what we're doing is we're counting how many times this number can go in to 3,048, but we're going from most significant. We're doing it in groups of thousands, and then groups of 100, and then groups of 10, and then groups of individual 12s to quickly close in as far as we can on the number 3048 with 12s, and before slowing down as we get to the minute details. Because already we've gone, alright, well, why go individual 12s when you can go in groups of 1,000? So you go 1,200, 2,400, 3,600, oh, too far. Okay, so 2,400. Great. So we went in via hundreds of 12s, which is 1,200. Now we've got 600 left over. But, while we're at it, we can't just say how many times, we could just say how many times does 12 go into 600, but we're going to say how many times does 12 go into 64. We're not going to say how many times does 120 go into 600, but we're also going to say how many times does 120 go into 640. Because now we're asking how many times does 12 go into 64. The reason we do this is because since we're at this level of significance, we might as well bring in that 4 for the best accuracy. So now we say, well, 12, 24, 36, 48, 56, and then we got, 12, 24, 36, 48, and then it goes 48, and then it goes straight to 60, and then it goes 72. 72 is too fast, so 60. So you take away 60, you get a remainder 4, and the answer is 5. Because basically 120 goes into 640 5 times, which means that 12 must go into 640 5 times, but there is a remainder of 40. There is a remainder of 40, not 4, but 40. But we have to write a remainder of, we could keep closing on the gap with 12 going to 40 so many times, but we can't because we're not at that level of less significance. We're still working with basically what I would call low resolution. We're gonna just do the bulk of it first, and then we're gonna close in on the finite details. So while we're closing in on that 40, we might as well bring in the 8. Now we're finally to the lowest level of significance, the 1. This is also where we're at our finest, literally. 12 goes into 48, 12, 24, 36, 48, 4 times. And that gives us the number 254. This video is probably a bit confusing, but if you watch it, if you did watch it and you understood what I was saying, hopefully, or you just go over and over and try and figure out exactly what I mean when I say what I'm saying, hopefully you found something really cool in this video, or intuitive, or learned something new. Maybe you didn't, maybe it was too confusing, maybe it would work better if I was trying to tell you this in real life, but this is why division works. But I probably won't show this video till I'm done with the other ones, like how addition works and stuff. So yeah, thank you for watching. My name is James Ryan, and I've been your host. Peace out.